So we're going to do some more things with slope. Besides just sort of looking at a graph or getting an equation and finding the tangent line and everything, some questions you might be asked to do is to find the average rate of change or the instantaneous rate of change. So the average rate of change, sometimes rate of change is written with ROC for rate of change. Average rate of change between 1 and 3. It's always x values. That just means the slope of the secant line. So basically it's just saying find the slope between x equals 1 and x equals 3. So I'm looking at 1 and I'm looking at 3 and I subtract the y's and subtract the x's. So it would be 6 minus negative 2 over 3 minus 1. And I get 8 over 2, which is 4. Now, same problem. Let's say instead that it wanted us to find the instantaneous rate of change at x equals 2. Might also say f prime of 2. So basically what's going on there is we're trying to find out what the slope is at 2. Well, we don't really know the slope at 2. All we can do is estimate. So what you're going to do is you're going to find the slope to the left side of 2. Then you're going to find the slope to the right side of 2. And then you're going to average it. So if I start with the left side, that would be 0 minus 1 over 2 minus 1.5. And you get negative 1 over 0.5, which is negative 2. If I do the other side, starting with the 4, it'd be 4 minus 0 over 2.5 minus 2. So we have 4 over 0.5, which is 8. So on one side of 2, the slope is negative 2, and the other side, the slope is 8. So what we do to figure out or estimate the average rate of change is we add that together and divide by 2. So 8 plus negative 2 divided by 2 is 3. So we would estimate that f prime of 2 was 3. And anytime it asks you to do that, you just sort of look at the table and you find the slopes around to as close as you can get to estimate it. Now, sometimes it might ask you to estimate f prime of 3 or f prime of a number. And the key word here is estimate. That means we're not going to be able to find it exactly. If I use the f of x plus h formula with ln of x, I'm going to get something crazy that you can't solve. So we have to estimate another way, and we're going to do it similar to the way we just did on that last problem. So what we're going to do is we're going to put 3 in the middle of a table, and we're going to get really, really close to 3. So there's lots of ways to estimate, but to make it easier so we all estimate the same, we're going to go 0.001 around 3. So on the left side of 3, it'd be 2.999, and on the right side of 3, it'd be 3.001. And we want to figure out the y values at those places. Because we're using the calculator, we can just plug it in the calculator. I don't need to know exactly what those values are. When I write them down right here, I can just write the symbols. I do need to be very, very careful in the calculator, though, to carry the whole decimals through whenever I find the slopes. So I'm going to start off by finding the slope of the left side of 3. Sometimes we can write m left, meaning slope on the left. I'm going to start with the y's, and in my calculator I'm going to put natural log of 3 minus natural log of 2.999. I got 3.333 times 10 to the negative 4th if you're doing it with me. And then divided by 3 minus 2.999. Now I'm keeping my whole decimal in the calculator. I'm not rounding it. And when I divide that, I get 0.333, lots of 3's, and then 889 and 889, and it just keeps going. And I'm going to store that in the calculator. I'm just going to keep it on my calculator I'm not going to get rid of it because I'm going to use it in a minute. So then I'm going to find the slope on the right. And so this time I'm going to start with this one and go to the natural log of 3. So natural log of 3.001 minus natural log of 3. Again, I got some strange times 10 to the negative 4 number. And I'm going to divide it by 3.001 minus 3. Be really careful about those parentheses if you divide. I got 0.33327, and it just keeps on going. So then I'm going to go up and I'm going to grab that first one plus grab the second one. So these two numbers right here, I'm going to add them and then divide by 2. So we're going to estimate that our slope is 0.333, and we're going to round it to 3 decimal places. That's a lot of calculator work on this problem, but it's okay. That's what I'm expecting. Anytime they ask us to estimate the derivative at a value, it's a lot of calculator work. I do want to see like a little bit of work showing me what you're doing, that you're getting the slope on the left or the right or whatever. But you don't have to show me every piece of work on that problem. Okay, another thing that it might ask you is the derivative positive or negative? And they give you a function. Well, you can just sort of graph this. I know that cosine looks like this. I know that this starts at 0. I know that this is at 2 pi. So this must be at pi because that's halfway between. So pi over 2 must be right here. There's not really much work to show except to think about the tangent line. If I drew the tangent line at pi over 2, it would look like that, or something like that, maybe a little bit more steep. And I'm thinking about the slope. This represents slope. Well, the slope of that line is negative, so my answer is negative. So some problems like this are really easy if you know the way the graph looks. You're just kind of thinking about the graph and thinking about the tangent line. All right, another question might ask you to think about f prime of m, f prime of n, f prime of r, f prime of p, and f prime of q. And what it might ask you is for you to put those in increasing order, which means that you want to start with the negatives, then 0 if there are any, and then positives. So the biggest negatives will come first. Alright, so what I do is I sort of separate this. Okay, I know that m and p are both negative. Well, I'm just going to kind of think about it and draw some lines here. There's p, or m. There's p. To me, it looks like that m is steeper, so f prime of m is going to come first because it's the bigger negative. And then f prime of, I was right in the first time, f prime of q will come next because it's still negative but not quite as steep as m. Alright, so that's my negatives. Then I'm going to go to my zeros. N is 0, so it's going to be next. Now I'm going to look at my positives, and I'm going to think about my tangent lines. Looks like R is more steep than P, but since they're positive, that means that P will come next, and then R. So basically, you're just thinking about the tangent lines and thinking about how steep they are, and you're putting them in order based on the numbers. So steep negative is a really big negative, and then it goes from there. Alright. Another question it might ask you is like this, where they give you a function and they tell you where things are. And they might say, okay, is f of a bigger or smaller than f of b? Well, f of a and f of b is talking about the y value. So I don't have to find it exactly, I just have to know which one's bigger and which one's smaller. Well, b has a bigger y value than a, so it would look like that. The next one is f prime of a bigger or smaller than f prime of b? Well, I'm thinking about the tangent line. Well, f prime of a is steeper. They're both negative, but the bigger negative means smaller, so again, it's going to look like that. All Alright, then I'm going to look at f prime of b and f prime of c. Both are negative. There's b, there's c. Looks like b is a bigger negative. So that means that b is smaller. They don't always come out to where all of it's less, but that's okay. And then we have f of b minus f of c over b minus c. This represents the slope between b and c. So we're talking about the slope there. This represents the slope at c, which I'd already drawn in the purple. It looks like that b to c is a bigger negative than c. So b to c again would be less. Alright, another question that it might ask you, how fast is the population growing after 3 years? Like if this represented population and t would represent years or number of time, something like that. That last problem, if I were going to estimate how fast it was going at that time, what I would do is kind of like what I did on number 2, where we would estimate f prime of 3, and so we would make a table, and if we were trying to find out how fast the population was changing at 3, then we would put a 3 there, and they would get really, really close to 3, and then our population would be here. We would find those populations. I'm not going to do the whole problem, but we would find the slope here, we would find the slope here, and then we would average those to estimate the rate of change at that time. So here's your try problems. Here's the first one. There's 3 of them, so just know that I'm going to move from the slides because there's not a room to put all of them on here. So number 1 is estimate f prime of 0 for f of x equals 2 to the x. You're going to have to make a table. 0 would go in the middle and so on. Number 2, I want you to put these 3 things in increasing order. AROC is average rate of change. IROC is instantaneous rate of change. Number 3, I want you to find the average rate of change between these 2 values, and then I want you to estimate f prime of 3.